So welcome back. This is Yuvan Raj Murugan, and we continue our topic that is boiler temperature monitoring system. This is our core team. Myself, Yuvan Raj Murugan, and Sarvesh Ravi, Divashan Gopi, and then Viknesh Priyasamy, and then the last one is Gani Samurthy. The topic is signal conditioning. In signal conditioning, what is signal conditioning? The manipulation of an analog signal to ensure that it fits the necessary enter criteria for the next level. So we have a five different function for signal conditioning. The first one is attenuation, and then filtering, isolation, linearization, conversion. So each of the function is more contribute to signal conditioning. From the previous video, we already chose thermocouple type K for our temperature monitoring boiler system. So, what kind of a signal conditioning for thermocouple type K? The first one is cold junction compensation. The measurement junction that hot junction, and the reference junction is cold junction. And then the amplifier, the type K provide microvolt voltage signal, and then the signal require amplification to be helpful. And then linearization, the output voltage of a thermocouple is not temperature linear. And then the fourth one is filtering. Filtering remove noise and interference from thermocouple signals. And then we use a low pass filter and notch filters. The fifth one is isolation. The isolation, electrical isolation protects signal conditioning equipment from ground loops and excessive voltage. The last one is converters between analog and digital. We simply we simply say the DAC. The DAC, the thermocouples condition analog signal must be digitalized for processing or display.
There are a few problems that are encountered when you use thermocouple type K. The first one is small signal output. Thermocouple type K uses seeback effect, which produces a very small amount of voltage when it is tested. Usually, a Wheatstone bridge is used to overcome this problem. The second problem encountered is non-linearity. Well, in whichever measurement we use, the measurand and also the variable must be linear so that we can measure the output. However, in thermocouple, it is non-linear, which means the temperature and also the voltage output will never be linear. Hence, a tool to linearize this is needed.
Now I'm going to talk about problems that are encountered due to the usage of thermocouple type K. Varying unknown temperature at cold junction. Thermocouple type K uses temperature difference across hot and cold junction to measure temperature. To solve the varying unknown temperature at the cold junction, compensation techniques are employed to account of this fluctuation. One common method is using cold junction compensation technique. This involves measuring the temperature at the cold junction with a precise temperature sensor, such as thermistor or RTD. The measured cold junction temperature is then used to correct the thermocouple voltage reading. This correction is applied by adding the voltage equivalent of the cold junction temperature. Next is noise and interference. Small signal output from thermocouple type K is disturbed by electromagnetic interference radio frequency and the power line noise. To solve this problem, we need to ensure accurate temperature measurements. First, proper shielding and grounding of thermocouple wires are essential to minimize electromagnetic interference. Using twisted pair cables with a grounded shield can significantly reduce the impact of external electrical noise. Additionally, running thermocouple wires separately from power and control cables prevent noise induction.
The first issue that has occurred is the low output voltage. So, to overcome this problem, we need to condition the signal We shall raise the low voltage output of the encoder to a level fitting for digital logic circuits. This will be accomplished with an operational amplifier, also known as op-amp, a non-inverting amplifier. To overcome the small voltage output problem, this is the design for the non-inverting amplifier we've done using the breadboard. So to solve this problem using signal conditioning method, we have used 8 components. First off, two 1 kilo ohm resistors, and then a 741 operational amplifier, two 1 millisecond oscilloscopes, one 1 hertz zero point 0.1 voltage 0.5 volt sine function generator, and two power supplies which it goes under P1 and P2.
The next slide is about method to solve problem using signal condition. The issue is overbearing ambient noise. Solution is to eliminate noise. We'll be using low pass filter. For the background noise problem, we designed low pass filter. These are the component arrangement of the component. So on the left, we can see the voltage generator. On the top, we can see the oscilloscope, which is 100 milliseconds. On the right, we have two batteries, which is 9 volt, and in the middle we have the operation amplifier, and also two resistor and also one capacitor. Next slide is about low pass filter component that is being used in construct the circuit in Tinkercad. As we can see, we use one triangle function generator, one oscilloscope, two batteries, one operational amplifier, one resistor, and also one capacitor.
So for the summary, to get accurate type K thermocouple readings, the signals need to be conditioned. It uses cold junction compensation, also known as CJC, to fix difference in the temperature of the reference junction. Amplification to boost weak voltage signals, and linearization to change output that isn't linear. Electrical interference and ground loops are stopped, and noise and others unwanted parts are screened out. Lastly, analog to digital conversion, also known as ADC, turns to the conditioned audio signal into digital signal that can be processed. These steps create accurate and reliable thermocouple readings that can be used in many situations to measure temperatures correctly. And that is all from us. Thank you. Signing off from Group 15.